And Part D, the last part of this lecture, is understanding statistical significance. So statistical significance has some drawbacks. First of all, there can be publishing bias. Studies that don't reach statistical significance are not published. So if 100 studies are conducted on a topic and 5 of them yield significant results, those 5 will be published. But the other 95 that didn't get significant results will not be published. And so who knows, maybe those 5 results were just achieved by chance and there's actually nothing going on here. But that's the publishing bias, you need significant results to publish. The second phenomenon that is a drawback for statistical significance is called regression to the mean. Any result that's statistically significant is likely to be less significant if tested again. It's the law of regression to the mean, and an example that you can think about in your just everyday life. Imagine that a team has a near perfect season in basketball. What's likely to happen next season? They're likely to not be as strong. It's just when you have a real strong extreme performance, the next one is not likely to be as strong. Or imagine that you yourself are taking, you've learned some sort of a skill and you've done just an excellent performance. Your next one isn't likely to be as strong. That's just the nature of extreme results. And so those are 2 problems with statistical significance, which is mostly what we publish in quantitative studies. And so now research standards in quantitative studies prefer additional information. So the first, I'm only talking about 2 of several. And so effect size is the first. So you might have a statistically significant result, a result that falls into the tails of the distribution, but the effect might not be very big. So the effect size is a calculation that tells you how much the independent variable affected the dependent variable. Or in other words, it's the percent of variability in the DV that is explained by the IV. So it will be reported in a decimal between 0 and 1. So an effect size of 0.1 means that the IV, independent variable, explains 10% of the variability in the DV. And that the rest of it, 90%, is unknown what causes it. In social sciences, Cohen is the big name who concluded that 1% would be considered a small effect size, 9%, even that small a number, would be considered moderate, and 25% would be large. And then we also talk about practical significance, how useful or practical the results are in everyday life. So these are a couple of examples directly from your book. Here's the first scenario. Let's say that your study was interested in whether psychology majors engage in different texting practices than students in general. And you gathered data and you found out that your psych majors had a mean number of texts per day of 42.5. with a standard deviation of 1.24. And college students in general had a mean of 39 with a standard deviation of 2.82 and a p-value of 0.03. So significant finding. And your effect size was 2%, small, just above small. And so you look at your results and you see that the difference between texting 42 times a day versus 39 times a day is minimal. Like, what is the time that it takes, what amount of time is compromised in that very small difference? So in this case, you would find statistically significant result, but yet it has a small effect size, this 2%, and very little practical significance. What is the time difference? Less than a minute probably. So probably not worth much. Scenario 2, you found there was no difference in the mean texting frequency for psych majors. The p-value is 0.15, and we look for a p-value lower than 0.05. But the effect size was moderate. The psychology major, counted for 20% of the variability in testing. That's it's pretty decent effect size on the strong level. And so in this case, the psych majors, you can see we had the psych major sending 60.5 texts and college students in general at 39.1. That difference could be noticeable and important in terms of time spent texting, which could influence interactions with others or attention in class. So even though these results showed no statistical significance, they had a strong effect size and high practical significance. So this is how we work with these ideas. So you should be ready for practice quiz T09D and a summary. So we draw our sample at random from the population and use data from the sample to infer back to the population. Statistical tests utilize probabilities and the characteristics of the normal distribution to determine the odds of arriving at a result by chance. In statistics, we consciously err on the side of caution by testing the null hypothesis. Only if we can reject the null hypothesis can we conclude that the data support the research hypothesis. Type 1 error is a false positive, a type 2 error is a false negative. The consequence of each error must be weighed before setting a significance level. Finally, because statistical significance can be misleading, social science articles now request that researchers also evaluate effect size and practical significance, among other things. So I hope this was helpful content, and we'll go through more examples in class.